More than 168 million people in over 50 countries are in need of humanitarian aid. Highly violent conflicts are causing widespread hunger, displacement, human suffering, death, and destruction around the world. Now more than ever, there's an acute need for skilled humanitarian manpower to match the growing need. It's time to take action and grow your career in the humanitarian sector. Welcome to Strategia Netherlands. We are an international organization that aims at making development and humanitarian work more effective. We're an independent and private provider of online and distance learning in humanitarian courses. Our mission is to provide our clients with relevant and high-quality courses to propel them to the heights of their choice careers. With over 300 exciting career-focused courses to choose from at Strategia Netherlands, our students are imparted with skills that greatly increase their prospects for employment as well as value to employers. Our students work for international organizations such as the United Nations and national and international non-governmental organizations and various governments. You can now apply online for diploma and postgraduate courses with a flexible schedule that allows you to study and maintain full-time employment. Apply now for a diploma in monitoring and evaluation, diploma in conflict management, diploma in leadership and management, diploma in humanitarian logistics, diploma in community development, diploma in grants management, diploma in disaster management, diploma in water, sanitation and hygiene, diploma in gender development, and diploma in food security and nutrition in humanitarian emergencies. The cost for diploma courses is 800 euros, while postgraduate courses cost 1,200 euros. Visit www.strategianetherlands.eu for more information. Take action and register today.
Good morning, good afternoon, good evening, depending on where you're logging from. Welcome to another session. Our session today is data management and data analysis. And our presenter today is Dr. Joyce Wangari Ngugi. My name is John Karegwa. I'm the training director at Strategia Netherlands, and this webinar is sponsored by Strategia Netherlands and Capacity Africa. And before I go further, of course, I've noted that people have already started introducing themselves in the chat. I would like you to just tell us where you're logging from. Of course, we've started in the first 5 minutes and we're already 220 strong. Thank you very much, our M&A community, for supporting these sessions. And please type in the chat room so we know where you're logging from and we can welcome you. Syria, thank you very much. Syria, Somalia, Asante, thank you, Somalia. Ethiopia, thank you, Ethiopia. Lebanon, thank you. Kenya, thank you. Ghana, Afghanistan, Ghana again. Malawi, Nigeria, Cameroon, Zimbabwe, Malawi, thank you, our community. Tanzania, Nigeria, Afghanistan, Mozambique, Tanzania, Uganda, thank you. Malaysia, South Sudan, Sierra Leone, thank you very much. Cameroon, thank you. Iraq, thank you. Angola, thank you. Liberia, thank you. Uganda, again, thank you. Uganda, Tanzania, Cameroon, thank you. Yemen, Botswana, thank you. Ethiopia, and how they read this, Spain, thank you very much. Nepal, Iraq, Ghana, thank you. Uganda, thank you again. Thank you. I thank everyone for joining in. This is actually overwhelming. Thank you. Zambia, Somalia, Thank you. Bangladesh, thank you very much. Oriental South, Germany, thank you very much. Egypt, thank you. Gambia, the Gambia, thank you. Well, thank you. The whole world is here, and we welcome you to this session. And our presenter is Dr. Joyce Ngugi. I can see she's all set. The format is, as usual, we will have the presentation from Dr. Ngugi, and then we'll take questions and answers. I know we weren't able to come to you in time because of Easter, so the notice was short, but so we make it about an hour and a half to 2 hours max. And without further ado, I'd like to invite Dr. Ngugi to come in and do the presentation. So prepare your questions so that you can raise the questions after her presentation. And thank you very much. And it's a big honor to host you again. Thank you.
Thank
Dr.
you
Ngugi.
so much, Mr. John Karegwa, once again for this opportunity. I believe I am in good hands because I see colleagues, friends from across the world. It's been a series now. We've been doing this monthly, and it's amazing to see you all again. So I believe today we are all here for the single reason to learn more about data management and analysis for M&E professionals. And as usual, it's good to see that we have people from across the world and also people who may or may not know what data analysis is or what M&E is. And we also have experts in the room. I believe that we are all here to learn and grow together. So I will be calling upon each one of us to this opportunity to learn and grow together. Thank you. And I'd like now to begin my presentation. I hope you can all see my screen. So today I will be taking us through an overview of data management and analysis for monitoring and evaluation professionals. And I will be telling you a little bit more about myself. I am a researcher storyteller. So my name is Dr. Wangari. I am a multiple award-winning psychology scholar practitioner with over a decade experience in research, monitoring, surveillance, and program management. I'm widely published. I have presented papers in international conferences such as the American Psychological Association, APA, where I earned a global award. I also run my mentorship network with over 200,000 members called MHPSS Opportunities, where I provide lots of mentorship, teaching, coaching, and I teach on research methods, data analysis, scientific writing, among others. I am passionate about transformational learning and making this learning available to others. So I'd like to start off with a story. As I said earlier, I am a storyteller. So for those of us who may not be very familiar with what monitoring and evaluation is, hopefully you get to connect from the story. This is the famous fable of the crow and the pitcher. So this is an ancient observation of a crow's behavior. And there was a crow that was very thirsty. It was a hot and dry day, and it was looking for some water. So, you know, recent scientific studies have confirmed that the crow's behavior was goal-directed and was actually out of causal knowledge. Cause and effect, you know, causal knowledge. So the crow was not just simply conditioned. You know, in psychology, we talk of instrumental conditioning. And there had been a debate in the literature for a while. And if we think about it from an M&E lens or perspective, the objective we can say is that the crow needed to eliminate thirst. And the activity it ended up doing was dropping pebbles inside the pitcher. So what were the inputs from a program level? That there were some pebbles or some stones, as you can see from the picture there. There's definitely a crow and a pitcher. You can see the lovely picture there next to the tree. And what were the outputs of this process? That the water level rose. And some outcomes were that medium or midterm, the crow was able to drink the water. We can also talk of long-term outcomes, that the crow felt satisfied or quenched of its thirst long-term. Then how about indicators of the number of pebbles dropped? These were the number of pebbles that were counted, you know. The crow was only able to pick a pebble at a time. And so we can talk of indicators. And so if this was a program and we needed to check indicators of the water rising, what would we look for? That the crow is watching the level of the water in the pitcher rising. That would be the indicator. And so what are the indicators that the crow was satisfied? The level of dust was quenched or reduced, all right? So can you think of any other monitoring and evaluation measures, quantitative or qualitative, that are from this example? I'm always happy to see sharing in the chat. This is highly interactive. We do practical trainings and webinars under Strategia Netherlands. It's not just hypothetical. So again, my question, is there anything you see that you would like to add? For instance, we've talked about on a program level, somebody is asking if we'll get these tools later, all right? So from this story, can you add some other indicators, for instance? How would you know, how else would you know that the crow was satisfied? Yes, Charlene Thomas says, could we also consider the existing water level as well? Yes, that's something interesting that we would like to measure. Very well said, thank you. Somebody says there is an echo, not sure if it's on my side, or maybe check your side. I will be advised if it's on my side. So anyone else with any other, and please tell me which kind of measure it is, or indicator or outcome, all right? So Victoria Walker says, very long-term impact that the crow can survive and doesn't die of dust. That's a really good one. Somebody else is hearing the echo. So let me see if I can just close the window next to me. Excuse me. All right. So another one, the Crow Creativity by Mark Boiter. Thank you so much. So what kind of indicator input or output is that? Please label it. Really interesting, the Crow Creativity. I don't know where that belongs. Then there is quite a number of Pallavi data says, can we label or create level of dust and level of satisfaction? And then Vida says, I agree with you. I don't know what you agree with, Vida. And then Prince Levy says, how many pebbles were thrown in the picture? Keep going. Let's take some more sharing. So let's see if we have any more. Yeah, prolific and unlimited. Anthony says we must as well consider assumptions. Mohammed Ali says the quality of water. Now, this is getting really interesting. We might also get some qualitative measures from this group. Vida says the level of dust is the objective. Okay. And then Lita Kong says, I see no risk or assumption. We are not yet there, so no need. Possible risks, okay. Nicasio De Rosa says, Evans Kayati says, the stone where the crow is patching is an input. Really well said. I really like that entire level of creativity. So I see we are all thinking in data management and analysis terms as monitoring and evaluation professionals. Keep that coming. That's really well said. And please indicate which kind of measure you're talking about, all right, as we go along. So keeping the story of the crow and the picture in mind, we are going to have several learning outcomes from today's session. One, to define various concepts in data analysis and interpretation. So some definitions, definitely. And then to delineate how variables are classified and their variable types. Then to understand the basis for selecting appropriate statistics, and to establish how to interpret p-values. And lastly, to explain very briefly data management as it pertains to the data life cycle or journey. So this is what you will be able to demonstrate at the end of today. And some topics, we will talk about what data is, how it's different from information, some important sources and types of data, Then we will go straight into data processing, the process of coding, entering, editing, cleaning, modification of data, then manipulation of data. Talk about types, levels, and methods of analysis, how to choose appropriate statistics, interpreting p-values, and the role of computers in statistics. Then under data management, we'll quickly go over quality standards for fidelity and possible data contamination. So statistics is a vital tool that provides organizations with the necessary information to make good decisions. It is a body of knowledge. It evolved from 17th century. However, we know that the earliest mathematical work in the world is actually from Africa. Very famous work in Egypt. When we talk about the Black civilization, we also know several other places across sub-Saharan Africa where we can detect early mathematical work. So, but we talk about a lot of the jargon terms we use are actually from the 17th century European mathematicians. So we have two main types of statistics in the whole body of statistics. One is descriptive statistics, which focuses on the summary or display of data so we can quickly obtain an overview. Then we talk of inferential statistics, where we can actually deduce from a sample into a population. And we use parameters, not statistics. We call them parameters. Parameters allow us to make claims or conclusions about a population based on a sample of data from that population. So those are the two main types of statistics. We are all consumers of data, and we need to be aware of the potential misuses that can occur in this field. I don't know if any of you, when you go to the mall, or we call them in Kenya, the supermarket, if you go to the store, do you always read behind the pack when you're buying a product? Do you read the numbers there? Do you begin to think about percentage values and things like that? I don't know if you do that, but we all know statistics informed a lot of the decisions. For instance, recently in the global pandemic with COVID-19, we had daily measures, we had people projecting about how many more cases we were going to have. And that information, remember we used to get daily updates, was enabling decision-making in the field of health, which was informing entire economies. So definitely we are all consumers of data, whether we like it or not. Therefore, that is a very important body of knowledge. And for some students, it conjures up what we have to do to pass. But I'll assure you that statistics is something that you need to use every single day. So getting into the data science universe, you find that there is a host of employable and high income skills in the 21st century. I don't know if any of you are in these professions. Do we have any data scientists here? Data architects, data analysts, BI analysts, AI engineers, data engineers, machine learning engineers, NLP engineers, business analysts, statisticians. Remember that today we get to really understand a lot of the work that these professions do. A quick glance at what, they have to work the numbers all the time. And these people are always crunching the numbers. If you can master any of these professions in this century, then you're doing very well. It's not a profession that's about to go. It's actually growing at a very, very high rate. I can see actually that somebody has said there are data analysts. We have a few, so this will be good. During Q&A, I might call on you on some of the questions that are coming up. I am a social scientist myself, and I've been working in the field of M&E, so I will be happy to take that on a M&E perspective. And I'm sure we'll get a lot more data scientists coming in. So obviously, how to become a data scientist is at the heart of it is statistics. Then there's a bit of it that has to do with program skills, then machine learning, and now we have to talk about things like data visualization. And there's enough softwares to help with data visualization in order for us to see the beautiful display and patterns of trends and things like that. Then obviously data knowledge, basic mathematics is also at the core of that. So in this presentation, I'm targeting mostly those in the NGO sector, those working in M&E who have got to do program skills. And as I said earlier, I am a psychologist, I am a social researcher, so I do both quantitative and qualitative, but today I'll be focusing mostly on the quantitative side of things. So I'd like to take some more sharing now. What is data? How is it different from information? And what is statistics? Can somebody somebody is already asking, but in the comment section, please put your questions in the question Q&A section. Is it a must for someone to master all those data analysis packages, for someone to become a data analyst? A really brilliant one. Okay, so I've just asked you, so define data, differentiate it from information and statistics. So what is data? I see Kadar Hashim saying data is a collection of facts. Aminullah Shirzada, data is raw facts and figures. Amos Ali, data is unprocessed information, while information is processed data. Okay, that sounds like a rhyme. Zelalem says data is raw facts. Casimiro says data is an unprocessed. Okay, it's just agreeing with what, unprocessed information. Ganizani agrees. Data is information that can be quantified. Okay. Chakri Jackson, data is unprocessed facts. Philbert Nyoni, data is unprocessed information and information is processed data. So we're saying pretty much the same thing. And there's quite a lengthy explanation from Etungano. I may not have a chance to read it all, but it's amazing. Data refers to any collection of facts, figures, statistics, or any pieces of information that can be stored, organized, and analyzed to extract meaning or insight. Wow, the Zoom chat is going up really fast. This is amazing. So many people are describing data and information. How about statistics? I've not seen any definitions of statistics. What is then statistics? If we know what data is and we know what information is, you're all right. I haven't seen any wrong answer. So statistics, I see from Sushil Nepal, is a tool to analyze data to get the information. Alavi says statistics is the tool to analyze the data. All right, okay. So really interesting responses, keep them coming. Zara Kiran, statistics is what can explain the data. All right, yeah, so those three are actually interrelated. Data is the value assigned to a specific observation of measurements. It's just one of many definitions. So think about data as, value, just, a specific observation or measurement. And then how is it different from information? So we can also say that data are raw facts and figures. I think many of you got that pertain to a measurement of interest. Information, therefore, is what is derived from the facts of the data, okay? So information is used for the purpose of decision making. So for instance, if I had raw scores of salaries across different months, it's just a bunch of figures sitting somewhere, January, February, March, April, and I have different numbers. However, if I begin to process that and make it meaningful, then I'm talking about information on maybe the mean score or the average salary across the several months. That's the difference. And data is the building block of all statistical studies. So statistics is that body of knowledge that has to do with collection, organization, analysis, interpretation, and presentation of data. So we can also say data analysis is a process. So we talk about sources of data. I'll not delve into this too much. We know there are primary sources, which is straight from the field, or secondary sources such as available data. And then we have types of data. And today we will really be unpacking those. So we can talk of quant and qual. So quantitative data is about numbers. So remember, a variable is what has a magnitude. The word variable comes from the word vary, which means to change. So you can classify variables as different ways. You can talk about dependent, independent, moderating, mediating, confounding, especially within a study. Today, we are not going into that type of a classification. We'll go instead into the other types of variables, which is generally quantitative and qualitative. And I think in a previous webinar, we had unpacked this at full length. But when we say quantitative, we are talking about numbers. For example, percentage, weight, height, body mass index, BMI, age at first marriage, all those are quantitative. How about qualitative? It's when we explore the questions of why and how. So you can have qualitative variables such as the reasons for not using a certain contraceptive method. Okay, that's not something to be measured in numbers, but it's actually non-numerical. It's qualitative. Today, we'll focus a lot on the quantitative types of variables. So from this diagram, you can see that data can be measured with numbers, such as duration or speed, and we can talk about discrete or continuous data. Discrete are whole numbers that cannot be broken down, such as a number of items, okay? Then when we talk about continuous, we talk about numbers that can be broken down, such as height or weight, and we can have even smaller scales for that. And under that, we can talk about under qualitative data, non-numerical data that is categorical, such as yes or no, or eye color, okay? And so we can talk about 4 scales of measurement, and we will be delving into each one of them. The first one is the nominal, where data is used for naming variables such as hair color, okay? So you can assign numbers to different hair colors. I'm pretty much sure, although I cannot see all of you on video, that we all have different hair colors. I don't think we all have the same hair color in this Zoom room today. So if we wanted, we could actually name the hair colors just by assigning them numbers, right? Then the ordinal variables are data that is used to describe the order of values, such as 1, 2, 3, for different states. You can order them: happy, unhappy, neutral. See, a certain ordering. Then we talk about, under continuous variables, interval and ratio. Under interval is those with numbers with known differences between the variables, such as time. Really interesting. We will be going into all of this one by one. Ratio scale is numbers that have measurable intervals where the differences can be determined, such as the height and the weight. Okay. So what's the purpose of data analysis? We need to provide answers to research questions being studied. In this case, in the work of projects monitoring and evaluation, we actually need to answer what the project goal is. Okay, so we need to observe the distributional characteristics of data, the variance in the data, the different trends and patterns, relationships among variables. And that makes the information meaningful. We can also be able to see the salient features and to understand the distribution. So the uses of measurement are such as to give the size or extent. So when we assign a number to a variable, this is very important because it will then determine the choice of the relevant statistical method. And so we need to provide value for magnitude or size or extent of any phenomenon or variable. And that gives us also a basis for comparison. So this one I had to add on who invented the scales. It was a psychologist, actually. I am a psychologist, so I have a soft spot for psychologists. Stanley Smith Stevens, in the year 1946, developed the best known classification with 4 levels or scales of measurement. So the nominal scale, the ordinal scale, the interval scale, and the ratio scale. So keep that name in mind. Stanley Smith Stevens is the one we credit for doing this work. So as we said, we are going to go one by one into each of the levels, and we'll start with the lowest level, the nominal, where we're talking about named variables. And if you see from this diagram, Each of the variable levels or scales has an additional attribute as we go up. So aside from just naming the variables in ordinal scale, we can also order them. Remember, we talked about the Likert scale of happiness. Today is Thursday. Most of us should be towards the higher end of the Likert scale of happiness because it's almost the weekend. So cheer up. So that's ordinal scale of measurement. How about interval? You have the naming, the ordering, and then we talk about proportionate intervals between variables, all right? That's interval scale. Then finally, the ratio scale, which is the highest scale of measurement, is where you do naming, ordering, a proportionate interval between the variables, and it can accommodate the absolute zero. So let me just check the chat to see a lot of people asking for the presentation. I think our curiosity is very high and we are not yet even halfway. Thank you so much for your keen interest. So on the first scale, the nominal scale, this is where we name, we classify people. We can use, I know if all of us went to high school, I know you were given a number when you joined your high school. Some of us remember the number to this day, while some people completely forgot that number. It's just a category. It doesn't mean you were quantified or ordered or arranged in any category. It was just for identification purposes, all right? So you might call it a matriculation number or admission number or registration number. That value has no numeric meaning in the way that you usually think about numbers. So if we say, for instance, we are going to give males in this audience 1, females 2, and any other gender 3, then we can just assign numbers to those variables, and that is very useful for the purpose of beginning the computations. So let's go to the next level, ordinal scale, and I'm going to give you an exercise on identifying some of these different scales in a bunch of examples coming up. So please pay attention. So under the ordinal scale, you now can rank order the items in terms of the degree to which they possess a characteristic of interest. So the intervals between the ranks are not necessarily equal. They're not equal. So people or objects with a higher scale value have more of the same attribute. So we talk about the ordinal scale being the second level of measurement. However, when we go to the interval scale, we have everything from the nominal and everything from the ordinal scale. And now we can talk about rank order. It allows us not only to rank order, but also to compare the different sizes of differences. We talk about intervals being equal with respect to the attribute being measured. So for example, the difference between 6 and 7 is the same as the difference between 51 and 52. At the interval scale, we can talk about equal measurements in between each value. Lastly, on the racial scale, this is just a repetition. I know I've said it different ways, that it has all of the properties of the preceding scales, the nominal, ordinal, and interval. It has a true 0 point, for instance, temperature. And the ratio of any two numbers is meaningful. Okay? The starting point does not depend on the units of measurement. So I'd like you to please indicate the number and the answer. If you can write for all of them, I'll be happy to read that in the chat. So name the scale of measurement for each variable below. 1, marital status of women. 2, identification number of study participants. 3, class size. 4, length of infants at the ANC clinic. 5, matric number, matriculation number, also called registration number. So let's take some charts. I see number 1, nominal is actually winning. I haven't seen a different answer for number 1. Number 2, I see ordinal. Okay, so number 1, it seems like we are all in consensus. It is a nominal scale. And if somebody would like to explain the reason why, feel free to type in the chat. Unfortunately, we are quite a number. I'll not open up for the voices. We'll hear the voices at the end. And number two, I see a lot of people saying ordinal. However, there's some people saying interval and some people saying nominal. So now that we have a difference in the second item, please explain why you think it would be interval or ordinal or nominal. So, so Tony Mugenyi says number one. What's the answer, Tony? Because you say because it consists of gender. Okay, Dorothy agrees nominal because it is naming without any ranking. Okay, good, well said. And then someone explains number two is nominal. Charlene Thomas says because it's only for identification purposes. Okay, all right. So I see that we have, under number two, we do have a variety of answers. So I'm very curious to know those people who said interval, why would it be interval? Okay, and then someone says number two is ordinal because it identifies the sex and then the ID number. Identification number of study participant. I'm not sure if that includes the sex of the participant. I'm not sure about that. Whoever said that. Okay. So please give your answer with an explanation. So number three, someone says it's interval. Why? Richard Ngalali, could you explain? So if you write an answer without saying which number, there were like 5 questions. I don't know when you say the reason, I don't know to which answer you're talking about. So Betty says the reason for nominal is that marital status can be in categorical order. Okay, that's really interesting. Okay, that you can actually have an ordered, version of the same. So now we are at number 3, and I see Sharon Longa saying it's interval but ordinal if they are divided in category of small, big. Okay. So Pallavi says class size will be interval. There cannot be 0.5 over person. Okay. And again, a variety of answers. Jack says ratio. Why ratio, Jack? Anita says interval. It sounds like interval is the most common so far. And Khalid City says interval because it defines the interval between 2 numbers. Okay, so I'm seeing quite a variety of answers for question 3. Now let's go to question 4. I see also there's agreement in question 4. A lot of people saying ratio. Okay, there's one saying ordinal. Waswa, why ordinal? Pallavi says ratio for number 4 because the size of a child is continuous and cannot be a fraction of a number. Okay. So you've got to say the reason. Otherwise, I won't read your answer. Dorothy Nabulovi says ratio because it has a meaningful 0 on the non-differential scale. Okay. Jack Onyango Otieno says ratio because size can be determined using all mathematical operations. Yes. Well said. Okay. Ratio, the length of the infant can be measured with decimal points. Yeah. Okay, and then on the final question, question number 5, metric number. What kind of a scale of measurement is metric number? Nominal, it is just a name. It can be either male or female, nominal. Item number 5, nominal. Getachew, were you answering number 5 or number 1? We already number 5, okay. Yeah, so, I'm just checking your answers in the chat. So metric number is nominal because they are only used to categorize. Someone said number 5 is ratio. So Kevin, why? Interval, Betty Fekade says because the metric number we can add or subtract. We can't multiply or divide. It will not be multiplied. Oh, that is so interesting. Getachew says number 5 is a scale. It has absolute 0. What, you mean interval scale or which scale get at you? Okay, so I see a variety of answers for the final one. So that is indicative that we all understood different things. Now, who is right and who is wrong? Let's look at each one of them. So when we talk about marital status of women, is it identification only, or can you put them in order? Okay, so those are the kind of things you want to ask yourself. Marital status. A lot of you say nominal. Okay, then identification number, that one I think we agreed, that's nominal. We have an identification number that's just for purposes of naming only. Class size would be interval, because we can do all kinds of, equal measurements between variables and things like that. Length of infants is definitely ratio. Okay. Matrix number, I think it's nominal. So if you have a variety of different answers, you could please explain if you have a different set of answers from the ones I've just mentioned. But that also tells me that we've understood different things, and maybe we need to go back on this section a little bit more in order for people to use their skills of measurement to determine the appropriate statistics. So remember, we said that the importance of measurement, it informs the way you design your instruments. It hints at the type of data collected, because we said a lot of the nominal, ordinal data will mostly find its way in qualitative work, but in quantitative work, it takes a lot more of the interval and the ratio scale. It tells what you want to do with the data, and variables, naturally quantitative, should not be categorized to avoid loss of information. So for example, if you have data entry or data collection of age, instead of asking participants for their age range, it's best to ask their specific age and also include a separate question on year of birth, so that you can calculate very precisely the date of birth and the current, date. So you get the actual age, not age range. So that's really important, especially for quantitative data entry, where you have variables which should be discrete, not categorized. So when we begin to analyze quantitative data, we talk about descriptive and inferential. Does anybody remember what we said the difference between descriptive and inferential are? So we had actually, I see people are still in the skills exercise, but we had actually defined the difference between descriptive and inferential analysis or statistics. Can anybody remind us? Yes, descriptive is for summary statistics, inferential for making inferences. Well, that's very well said. Hamisi, Faki, Hamisi. Descriptive describes the data at hand. Robert Otieno, yes. Kadar Hashim, it focuses on the summary. Potso, Molebati, it gives you a summary of the data. Alavi data, it's for visual representation of qualitative analysis, description. Okay, we could say that, but when we talk about descriptive statistics, we're not talking about qualitative, we're talking about quantitative, Alavi. And then descriptive is summarizing. Descriptive is parametric. Inferential is non-parametric. Qualitative mostly no. That's not true. It's the opposite actually. So we talk about parameter when we talk about inferential statistics, Anita Bagaba. Okay. And when we talk about descriptive statistics, we're just talking about the sample. Okay. So we had already mentioned descriptive versus inferential having to do with the sample versus the population. The idea of the inferential statistics giving us the parameters in order to make decisions, but descriptive being for summarization of a sample, just describing what you can see. So thank you very much, everyone. I think you got that right, most of you. Then we'll talk about 3 levels of analysis. We say univariate. Uni means single. Bivariate, like a bicycle, means 2. So 2 variables at a time, and then multivariate means 3 or more variables. So what are some methods of analysis? We talk about tabulating, adding items in survey responses. Sometimes, I think recently, most people have become so used to using some sort of way to calculate something that we don't really add up things in our minds like we used to in the past generations, okay? So tabulating is one way, okay? Crosstabs is a very common one, especially when you talk about bivariate. 2 factors relating them, that's crosstabs. Aggregation, to aggregate is to add up for an overall picture. Then you can talk about the opposite, disaggregation, is to break down the total situation into units. That's another method of analysis. Then projecting, that's forecasting. And we do a lot of projecting work in monitoring and evaluation. We use data to check what's going to happen, and we can predict and control a lot of things. So let's go into univariate analysis. We're talking about a single variable. Anybody remember measures of central tendency? So we can talk about the mean, mode, median, range, the count, the frequency count, how many number of items occur. For instance, earlier I had talked about the crow and the pitcher. So we could use that description to analyze, for instance, how many pebbles had to be added into the pitcher in order for the level of water to rise and for the crow to quench its thirst. Then we also talk about bivariate analysis. 2 variables. A relevant statistic is crosstabs, for example, the chi-square. T-test, bivariate correlation, bivariate regression. Remember that the choice of your method depends on the measurement of your variables. Then we talk about multivariate analysis, whereby we have 3 or more variables, such as multiple regression, logistic regression, binary multinomial, log linear analysis, factor analysis, multinomial analysis. So all of these are about 3 or more variables being manipulated in order for us to see the patterns or the trend. So there's a very interesting diagram here that really describes the rough guide to choosing a test, whereby we know that data analysis really begins from the theory, okay? So, the basic methodological approach that is used is very important because, data never speaks for itself. Facts just never speak for themselves. So data processing is how data is prepared for analysis. And then data analysis is how the data is now manipulated numerically in order to compare the data or the empirical evidence with theoretical explanations or theory. So you can see from the diagram, maybe the writing is a bit small, but you want to ask yourself, what does your data look like? And then from there, you'll be able to see from the kinds of variables they are, whether they are categorical or continuous, the kind of tests you need to embark on for the analysis of your data. So that's really interesting to learn that you need to know the scales of measurement used in order to choose the appropriate statistics. So we talk about quite a number of different statistics that can be done. Anybody heard of ANOVA, except the experts, data analysts, right? There are those of us who are new to M&D, new to statistics. I'm talking to you now. ANOVA, have you heard of ANOVA? That is where you're checking the possible effect of a single non-metric independent variable or factor on a metric dependent variable. So when we talk about an ANOVA, we're talking about an analysis of variance. We want to know the distribution from the mean, okay? One-way analysis of variance, okay? Then we can talk about simultaneous effects of n factors, which are non-metric, on a metric-dependent variable. So these are all different types of statistics, and depending on which scale you actually chose. So you can talk about the n-way analysis of variance, okay? Then possible effects of both metric and non-metric independent variables on a single metric dependent variable. Analysis of covariance, okay? then possible effect of one metric independent variable on a single metric dependent variable. We can talk about bivariate regression. There are quite a number of other statistics. If you want to talk about two or more metric variables or metric dependent variables, then we are talking about a multiple regression. Sometimes you want to determine the extent of the relationship between two metric variables. So you can use the PSO, product moment correlation coefficient, the PMCC, or the simply called PSO correlation coefficient. Then you can also be very curious to know the possible effects of metric and non-metric dummy variables on dichotomous dependent variables. So there is a binary logistic regression analysis that can be done. If there are more variables, then we talk about multinomial logistic regression analysis. So remember, all these are different names. If they are big names, you've never heard of them before, don't be scared. These are just describing different ways you can manipulate data or variables. If you want to talk about two categorical variables, then you can do a chi-square. So for example, age in association with categories of happiness, okay? So we say we are almost at the weekend and we want to measure how many of us are happy on the scale of happiness. And that's a categorical variable, okay? So you're either happy or not happy, and let's check against maybe another variable, which is also categorical. Then a difference between a metric dependent variable and a non-metric, two categories, is called an independent t-test. Then when you have test of differences between two metric variables in a pre-post test, so you're going to take a paired test at the beginning and at the end, at the pre-stage and at the end. So that's why we call it a paired t-test. You need to take two measures at the beginning and at the end, okay? Then measuring the relative importance of the metric independent variables on a metric dependent variables. We call that a beta coefficient. So we also know that we have other, we have the R square, that is the coefficient of multiple determination. You want to check the proportion of variations in a metric dependent variable explained by metric independent variables. Or you want to check possible associations among three or more categorical variables. Then we talk about a log linear analysis. So we have alternatives which are non-parametric. For instance, to the ANOVA, you could do a Kruskal-Wallis test. Another alternative, non-parametric alternative to the independent t-test is a Mann-Whitney test. And a non-parametric alternative to a paired t-test, you can do the Wilcoxon sign-ranked test. So all these are examples of different statistics that you can do. Ultimately, what you want to check for, you want to check for significance of the data. So that's where we go to p-value. And when you see the sign H, oh, we're talking about the null hypothesis. So if you get a p-value that's below 0.01 after all of your computations, then you have very strong evidence against the null hypothesis. Okay. However, if your p-value is between 0.01 and 0.05, you have more moderate evidence against the null hypothesis. If your p-value is between 0.05 and 0.1, then you have some suggestive evidence against the null hypothesis. However, if it's above 0.1, then there is little or no evidence against the null hypothesis. The section on interpreting p-value, I didn't want to go so much into that, but that's the point of doing all of these statistical computations in order to check not only what the patterns of data are, but are they significant? That's ultimately the question to ask. So if you can see from this summary table that you will get possible statistics from a number of measurement scales. And for instance, from the nominal scale where you have characteristics like identity, just a number that identifies something. You can have very many different examples, such as gender. Somebody had already mentioned male, female, colors. We had talked about the colors of our hair, and I bet you they're all different from this group here today. Different examples there, and you can see you can get possible statistics from the nominal scale. Frequency distribution, which was at the first level univariate, we can talk about percentages, binomial test, chi-square, all of these different statistics that you can do. It actually is dependent on the scale used. Then for the ordinal scale, you can see that that's about ordering. So numbers that are ordered, like attitudes, preferences, opinions. So if I ask you your opinion today of how happy you are, then we can actually do that statistical computation. And we can do everything that's being done with the nominal scale, like frequencies and things like that. And in addition, we can add quite a number of statistics, as you can see there, all the way to correlations. Then from the interval scale, here we are comparing intervals, okay? So again, you might find that some examples there are like attitudes, opinions, preferences, index numbers, and all the ones from the nominal and ordinal scales, all those statistics can be used, plus a bunch of more, okay? T-tests come in there, Pearson correlation comes in there. Then obviously from the ratio scale, here we can talk about comparison of absolute measures and proportions. So for instance, something like income. Income is in the ratio scale. So you can do all of the statistics from the scales above, and on top of that, you can even add a few more, like coefficient of variation. So remember that our measurement scales are what you can look at a survey or a data collection instrument, and from the scale you identify, you have an idea of the statistics that you would need to do on the quantitative analysis. So let's talk a little bit about the use of machines in data analysis. And did you know in the Dark Ages that the first item that was ever used to do any computations and calculations was called a slide rule? If you know that, that's a fun fact from history. So it is right there, you can see it there. So which is the simplest machine you have ever used to compute numbers? Let's take some sharing in the chat. So somebody saying 1975, no, that was just a citation. Actually, that slide rule was used much earlier, but you can go check out that citation and learn more about that. So which other computational tools have you ever used to compute data? Which was the first one you ever used through school? I want to see if someone will get this right. Abacus, calculator, that's the answer I was looking for. Thank you. Yes, an abacus, a calculator. We've come from very, very far. Before even the SPSS, the tool I was trying to get was actually the calculator. So a lot of you have gotten that right. Scientific calculator. Excel, somebody has mentioned Excel. Yeah, let's keep hearing that. Sticks. Oh, that's interesting. A lot of, especially if you went to school in the rural areas, you actually learned using sticks. And if you are in that generation, I'm not sure if now we are going back to sticks and straws and stones, or we are going away from that. I can see straws, stones, counting. Nobody used their fingers to count. Okay, you are a good class. Nobody here used their fingers. Stones, bottle covers, bottle tops, counters. Fingers, okay, somebody used their fingers, okay. I first had abacus from my daughter recently. We used sticks. Oh, wow, okay. Calculator, stones. So the crow in the picture was not silly. They were actually statisticians, right? Pencils, very well done. Yes, a lot of us used pencils actually growing up to count. Yeah, very well said. Those are actually tools that you used. Tallying, yeah, you'd write some tally numbers, and then when it reached 5, you'd cross the 4, right? Excel, bottle tops, yeah, good. I see we have a wide variety there. Those were the machines you used to compute numbers. And now we can credit some more sophisticated software. And they have various roles in data analysis. again, today I'm not covering the qualitative ones. So I'm not going to go any deeper into some like NVivo, which are used for qualitative work, you know, but this is a nice picture that has different names there: Stata, MATLAB, Atlas TI, Minitab, SAS, MaxDa. There are quite a number of tools, and I'd like to focus on SPSS just because I'm a social scientist, but we know now that even all the rest have their latest versions. Every day there's a new version. Okay, so the statistical package for social sciences is more manual than the rest. Some of them are programming languages, you know, and they have very sophisticated kinds of, you know, calculations and computations. So those are some software that are used for quantitative data analysis right there. And obviously they can be compared with their features and properties. Each one of them has a newest version. There's not their current version even now. It has improved. I think SPSS, we are so it was released in 1968, and you know, we know that it is very good tool for non-statistician because it's user-friendly on the interface, and it has easy to use drop-down menus. And so a lot of these applications, unfortunately, have a hefty price tag, and a lot of students or M&D professionals may not afford it, but companies do purchase these things because they help with data analysis. So quickly on the overall data management as I finish, it is a set of disciplines and techniques on how to process, store, and organize data. So we talk about the importance of having standards and policies or guidelines. So we do have data quality assurance or audit. The idea is to preserve the fidelity of the data. We talk about formats of data, the pros and cons for each format. You know, you'll see .csv at the end of a data file, for example, and then access controls and authorization. Who can access the master file? All these are very important. Data sharing policy, backup plans, encryption or data security. Then we talk about the entire procedure from sample selection, data collection, recording, storage, and collation, which is bringing together. So if you could think of those five stages of data management, what are the possible sources of contamination, of data contamination that you think could happen at any stage? For example, sample selection. Do you think, I mean, there's no data that's completely perfect. Data always has margins of error. So which one do you think would be a potential source of contamination, for example, when we talk about sample selection? Let me take some sharing from the charts. So, okay, somebody is also asking how to contact me. I think I provided my website, wangari.africa, so you can reach me through that. Bias, yes, bias during sample selection is a very common one. Please feel free to say a little bit more. Sample at the sample selection stage, also collecting data from the wrong source. Yes, Kevin. Misrepresentation of the population, very popular, very common. It's a very common source of data contamination. Okay, data collected from the wrong audience, biasness of the scholar. Okay, sampling from the wrong target population, very well said. You know, this is all very well said. Duplication of the data, Tony Ngugi says. Interviewer pre-knowledge. So sort of like they already know the answer before going out to ask. Yeah, using the wrong tools to collect data. Incompetence in enumeration. Yeah, sometimes it's you directly doing the work, or you have hired a few assistants and they're not competent. They're not well trained. Cooking of the data. Yes, it's very common. Reliance on secondary data alone, validity problem, Hawthorne's effect, interpreting data in the wrong. This is all very well said. So those are some possible sources of data contamination. And that's really important to note, because at any point, we've got to include quality checks in data We've got to make sure that our data ultimately serves the purpose. And so data management is really important. Remember, there are three major qualities of good data. It has to be accurate. It's got to measure what it's supposed to measure. It's got to be valid. Then it's got to be complete, no missing data. And then reliable or reproducible, especially when we talk about quantitative data. That if it was collected several times from different samples in the population, the results would be pretty much the same. So in summary, data serves as the building blocks for all statistical analysis. You can classify it variously, but we took the quantitative, qualitative classification, and scales of measurement enable you to choose the appropriate statistics. So when we talk about nominal data, it's just categories with no mathematical comparison. Ordinal data, it's just like nominal data, and additionally, you can arrange the observations in order. Interval data has that additional capability over the nominal and ordinal level of calculating meaningful differences between observations. For the highest level ratio, it takes all the characteristics of all the other three, and additionally, you can express one observation as a multiple of another. So we talk about data analysis types: descriptive, inferential. That means sample and population level. And then we talk about levels of analysis. We've talked about univariate, bivariate, and multivariate. So I'll now be happy to take any comments or questions. Thank you.
Thank you very much, Dr. Joyce, for the presentation. We've learned so much. Before we take questions and get answers, I want to thank you. We have 300, 400 people in the room. Thank you very much for the support. I would like to, we always like to share resources, and I'd like to introduce Moise from AAM Digital. They have a software on data analysis. So Moise, if you can take 5 minutes to introduce yourself, and next month we'll give you a session to talk about what your company is doing to enable data analysis within the development work. So Moise, please take a few minutes and introduce yourself. Thank you very much.
Thank you so much, John, for this opportunity. Hello, everyone. Good morning, good afternoon, good evening, wherever you are joining from. Greetings from Germany. As John mentioned, I work for ARM Digital. We are a registered digital public good and an open source software solution provider for NGOs. We are working on a mission to enable NGOs to be data-driven. We are a group of software developers, project management professionals, and change management experts. And the reason why I'm here is we recently conducted a survey on data management practices of NGO, and learned a lot of interesting insights. I'm actually happy to just share some the key findings of the survey also in the link below. But what we really learned is there is still a big gap in terms of understanding of what are currently the digital tools that are available for the sector. I've just shared the link of our survey. We really learned that right now we really need to bridge this gap in terms of the understanding about what are the digital tools, how do we even go about like introducing digital tools on the field, how do we support the team to like really adopt digital tools effectively. And the reason why I also like reached out to John was we really want to use this as an opportunity to create a learning experience for all of you, where we would like to just share in terms of what are the possibilities available for the NGO sector, and at the same time also share a lot about the different tools. So for example, ARM Digital, as I mentioned, we are an open source tool. We are a case management solution provider where we enable organizations to digitally track individual program participants. So it really helps organizations to scale their intervention and maintain the rigor and impact. Similarly, there are other tools also which we know of which are available for the NGO sector. It is just that we don't have a platform to share about them. And I really look forward to the next webinar where we would be also like sharing our experience and our expertise and our learnings from the sector with you all. And I would look forward to like seeing you in the next webinar that that Strategia organizes on this topic. Thank you so much, John. Over to you.
Thank you very much, Moise. He's from AM Digital, Berlin, Germany. Mark the date, 19th of May. They will run a webinar on what they're doing for development community with regard to data analysis using their software. Because we are midterm, before we go to the questions and answers, put your questions ready. You can see his email there. So 19th of May, we will have another webinar on that. Just to mention, these webinars are basically a snippet. You need to participate in a real program. And I want to share two programs coming up. We have monitoring and evaluation workshops in here in Rotterdam and in Nairobi, Kenya, with our partner Capacity Africa. So mark the dates, 15th and 18th of May in Nairobi. Training in monitoring and evaluation, which has a whole day session on data analysis and data management. And the 5th to 9th of June in Rotterdam, Netherlands, the same workshop on monitoring and evaluation. So let's take questions. Thank you very much. Dr. Joyce, be on standby. So if you have any questions, please raise your hand and we'll take the question, and then Dr. Joyce will be happy to respond. Thank you. Raise your hand if you have a question, and I'll take the question from you.
So maybe I can start with the ones in the Q&A.
Yes. Start with the ones in the chat room, and then we'll see if we can take others from the participants. Thank you, Joyce. Thank you.
All right, so I'd like to take some questions here. Give an example to differentiate ratio and interval scale. I think we did that. Not sure if you had come in late, but as we say, the difference between interval versus ratio scale comes from the ability to dip below zero. So interval scales hold no true zero, and they can represent values below zero. For example, you can measure temperatures below 0 degrees Celsius. We use Celsius. Some people here use Fahrenheit. For example, -10 degrees, okay? But then we say for ratio variables, they never fall below zero. So that is the example right there. I hope that answers you, Benjamin Rock. Then there was another one, please define metric and non-metric variables. So thank you for that. That's a really good question. We've had, I mentioned that a few times and I did not define it. So, you know, we talk about metric data. Data is such as interval data, ratio data, and non-metric data is like nominal and ordinal. So when we're talking about the two, non-metric data is data collected from binary scales, nominal scales, ordinal scales. So they are jointly termed as non-metric. That means they do not possess a meter. The idea of there is no meter with which the distance between the scale values can be measured, okay? So for example, nominal, you're just naming male, female. Ordinal, you're just ordering them, okay? Metric data though, now we're talking about a meter, and you can actually measure equal intervals in between each of the variables. I hope that is clear now. Thanks for that. What are the challenges in data analysis? Again, we captured that. Quite a number of possible sources of data contamination bring about the challenges in data analysis. And that's another way to talk about how do we conceptualize, you know, when we've had, even before data analysis start, can we already see that the data will be biased, for example? Yes, we can. From data collection, we talked about all the way to data collation, which is bringing together the interventions. Yeah. So I'm seeing a lot of questions about when is the next meeting and when do you do trainings? Yes, I do trainings also on SPSS. Yes, I see that question. So can you share some more software for qualitative data analysis? I think I mentioned a couple. NVivo is one of them I'm very familiar with, and there are many more. Some of these questions are facts, so you can always check up. The softwares are being invented by the day and they help with computing. However, today our focus was mostly on quantitative, not qualitative, right? So somebody asks for practical SPSS training that can always be organized. Could you share if the data analysis software for qualitative data? I think you are the second person who was asking the same thing. And I think today I did not delve into the qualitative one, but I've already mentioned some of them. Which test is the best to compare case and control group? So now you're talking about experimental versus control group. So which kind of tests? Let me see. And I'm also seeing some answers. These are really lively group. There's a lot of people also asking questions in the comment section and also answering the rest. So thank you for that. So I'm going to swing back to that one later. So question, how practical is it in using stringent data collection and analysis during an M&E exercise over a short period, such as 3 to 6 months? What types of data can you easily use? Examples? Okay, so that sounds like you can do a pre-post test, for example, because this is an M&E exercise over 3 to 6 months, okay? So it is quite practical for you to use data collection and analysis methods. I'm not sure what actually you're studying, William, so I don't know which data, which types of data you are talking about, or what maybe you can tell me a little bit more about that, William already. Okay, what are some principles for data management? I already talked about that when we talked about ethics, quality, fidelity. We want to make sure that the data is representative of reality. When we do data analysis, we are manipulating variables and data for the process of processing information that can be meaningful in reality. So data management is all about that. About missing values, yes, this happens a lot in LLM. In data analysis, we have a lot of times when we have missing values, and there are ways to compute when you have missing values, and you can actually, still get some analysis, some statistics done even with missing values. We talk about at least up to 5%, For instance, if you have a survey and you're missing up to 5%, you can still analyze that data with 95% of the responses in the survey. So I'm skipping the questions which are about asking for the recording and when the next M&E session is. So Usman Angara says, how do you convert ordinal to ratio? For example, you have collected age in range and you want to convert to actual age instead. It's actually not humanly possible unless you go back and ask participants, because when you collect data that's already grouped, then it becomes really difficult to have discrete.
Unlike someone that is here, we are together for years.
Okay, somebody please needs to mute. So I hope I've answered you, Usman. All right, Hamisi. For control and treatment, we can use difference in difference. Thank you for answering that. That was a question asked earlier. How do you analyze data for case and what we call expressions and the like? Yes, that's very correct. When is the right time to decide for a data analysis tool? These are really good questions. Somebody please needs to mute. So this entire process of data analysis starts at the methodological stage. When you are designing how you will go about what you need to answer. What's the objective or question? Remember the story of the crow and the pitcher? And then what kinds of data you then need to go collect? And then from there, you also have the data analysis plan even before you collect the data. So remember, designing at the project design stage is the right time to decide the data analysis tool. And that's the reason why people even indicate which software they could use, and even deeper, which analysis methods, not just the software, but exactly which tools you will need. It's all at the design stage. So the analysis employed depends on the measurement scale of the dependent variable. Yes, you got that right, John Bogo. We're talking about both variables, dependent and independent. And if you want to employ a certain analysis, then you've got to ask yourself, what's the measurement scale? So if we can go back to the crow and the pitcher example, you saw that there were so many different things that we could test. And for those who came late, I'm just going to show that again. Let's see. Okay. So let me share screen. So we already said, for those who came late, that, for example, from this story, you can already see a lot of different things that you can test. And so it's from there that you can decide, which statistics that you choose appropriate to the kind of analysis deployed. Can we use descriptive statistics in measuring the height of people? Oh, yes, most definitely. And which descriptive statistic would you like to use? You can use the mean, mode, median, range, any of those measures of central tendency. You can take account, frequency, and then you can use quite a number of different descriptive statistics in measuring the height of people. Okay, so you're asking Delson, when is the right time to decide? Yeah, I've already answered that. That's at the design stage. Which softwares are the best for data storage? Really good question. Can you please have a quick practical example on how to fill missing data? Today was an overview of data management and data analysis. So please just note the audience that was curated for today was those of us who are in the field of M&D and who may not be, who are curious to know. Back to you on the quick software for data storage, but if anybody knows the answer, you can also type in the chat. I say that we are all Johnson says, which is proper to deal with the start between null and alternative hypothesis. I see behind that, and I have my colleague there typing the answer, so let me leave her to eat. It's a really good question, though. So why do people in studies only kind of seem to focus or highlight the null hypothesis? What's the difference between null and the alternative hypothesis? A lot of your questions are inviting us to go deeper into data analysis, not even directly what was shared in the presentation. So, how do you use DHIS2? I believe that's a software. Could you kindly share your thoughts on the emerging predictive technologies like machine learning and AI in terms of how they will impact data science? That's a brilliant question, Jack. I feel like we can't avoid it. We can't escape it. There's been a buzz now about ChatGPT. Then obviously Google also came up with their own, and there's all these big tech companies right now really anxious to take the market share of the latest artificial intelligence. I feel like they will impact data science in a great way because we are now already in big data. We already have a lot of our information taken and contributing to a lot of big data. So it's here to stay. I think my thoughts on the emerging predictive technologies would be to check what opportunities are there and what, the risks are. Yes, Mina, what is descriptive? We already said that. We actually differentiated descriptive from inferential statistics, and descriptive statistics have to do with the sample or just quickly getting a summary of how data looks like. And when we talk about inferential statistics, we're talking about inferring or inference from a sample to a population. How do you link data from different departments from one program organization and from different organizations that have important data? Also a great question. I'll swing back to that. Now, let me see if there are any raised hands. I had seen some raised hands as well. And I see also a number of questions in the chat. Hi, Kaushiki Mishra says, I have studied development. I'm very familiar with basic level of understanding of M&E theory. Now I want to learn data analysis and I have weak background in statistics. From where should I start learning about data analysis? From basics. That's a really good question. Actually, it's possible to get a lot of tools from the internet. You can basically start with online self-taught courses, self-paced and things like that. Okay. So from basics, you can get statistics training also at Strategia Netherlands. They're quite, if you are more interested in live type of training, I think you'll be able to get quite a number of them like today, right? Today was just an overview type of, Okay, so Benjamin Robb says, the slide for p-values, I found it important as I've been just either rejecting or accepting a research hypothesis. Yes, I can go back to that slide. Not a problem. So I talked about the significance and how you interpret the p-value after you've completed all the statistics. So let me see. Oh, now I see the raised hand. I wasn't seeing the value. I'll go to them shortly. So let's see. We have various categories of p-values. And I had mentioned that I had interpreted each one of them. So if it's below 0.01, very strong evidence against the null hypothesis, and so on and so forth. So I hope now you can see that slide. All right, Benjamin, I hope you're well answered. Valentine, thank you, Dr. Joyce, for this informative session. Is there any difference between an M&E specialist and a data analyst, or maybe consider an M&E specialist as a data analyst? No, they're distinct. However, you can have skills in both fields as both we work closely with each other. From the last webinar, we realized that there were so many questions on data. And so we get to appreciate the work of people who do this as their main work, data analysts, data scientists, and things like that. Okay. My thoughts on Kobo Collect tool, Virana Bogiri. I think it's a great tool for people who need to use mobile applications and go to the field and collect a large number of information. Tools like those always make it much easier than manual data collection. Sometimes, papers shall get lost and things like that. Okay, I don't know what that is. AkaQ, you typed a sort of a formula, Windows key plus PRTs. SPR screenshot. Okay. Oh, that's how you do that. Okay, I didn't even know that. Today I'm also learning a lot of things. All right, great. So let me take some raised hands. Please show the raised hands again. I can't see them anymore, or line them up for me, please. I'm not able to see trying to see where the raised hands were. Okay. So a lot of the questions that are still coming in are being answered live. My colleague Ruth is actually writing because we realize now we have more questions than the time remaining, which is about 1 minute. So let me also request that any outstanding questions can be handed over to us through me through the organizers, and I'll be able to answer those. All right, thank you very much, everybody. And it was a lovely audience. Over back to you.
Thank you very much, Dr. Joyce. I think you will continue to take the questions directly, but before I hand you over the microphone, just to announce that, because I can see that in the chat room, people inquiring about the slides. We normally don't share the slides, but we have the recording on our YouTube channel from tomorrow. Check our YouTube channel and subscribe. Strategia Netherlands, and there are about 57 other videos for the different webinars we've done on monitoring and evaluation, project management, proposal writing and fundraising, water and sanitation. So just log on to the channel and you'll have the video there tomorrow, so you can follow through the discussions in case you miss something. So Joyce, just continue with taking the questions, and then we continue. We learn from the questions, so that then we're able to prepare the next webinar. So so it's very, very much in order that your questions are answered exhaustively, and that then we know the needs for our partners. Then we can prepare the next webinar. So let's continue. Thank you, Joyce.
All right, thank you. So Prince Levy asks, how would you prioritize and manage competing monitoring and evaluation demands from different programs? That's a really good question. And the importance of having a plan actually makes you effective in M&E work, because we will always have different demands from different programs, but we have to ask ourselves, out of all the great work and wonderful work that has to be done in the world, which one is the most efficacious, that will bring an impact? Which one is the most efficient, best use of our time and resources? And which one is effective, doing things the proper way, getting things done properly? So efficacy, effectiveness, and efficiency is what I would look for if I have to prioritize and manage demands from different programs. I hope I've answered you, Prince. Okay, so I'm seeing a lot more questions. Adan has asked again, how do you use DHIS tool? Somebody can please take that up. That's a software, I'm not too familiar with it. So kindly summarize the simple definition of measurements, giving examples. Thank you. Then I will do that shortly. David asks, how can one join your mentorship group? I already gave my website, wangari.africa, if you want to contact me. And then thank you for that, Usman. I also noticed you say I need to correct the last p-value group. It should be greater or equal to. So I did not put the equal to sign. I'll add that. Thanks for that. And then Mina Ogbanga says, I have many questions like, must all projects use hypotheses? That's a really good question. So we talk about quantitative studies, mostly requiring hypotheses. And then for the simple definition of measurement, prolific, and somebody needs to mute, please. Okay. For the simple definition of measurements, I think this slide will summarize it, Anthony. Nominal scale is just about definitions. Ordinal scale is about like the orders, ordering the numbers. Interval scale is about comparison of intervals, and ratio scale is about the comparison of the absolute measure, the proportions and things like that. Somebody needs to mute, please. Okay, thank you. So I actually see the answer. Somebody is answering. I think somebody had asked what is linear regression. So you're saying linear regression, Hamisi says linear regression models the relationship between variables as a straight line, while nonlinear regression models the relationship as a curved line or function. Yeah, very well said. Really happy with all of the interaction class. Different questions coming in. So let me see. There are any unanswered ones.
But I don't think whether the quite bad.
Somebody needs to mute, please, kindly. Okay, so is the use stage in data analysis the most important? Kadab Hashim questions about that. Which stage of data analysis is the most important? I think that because the goal of data analysis is to process raw data or facts into information, I think the final stage of use is the most important. How do you actually use it in reality? So thank you so much for that. I think all of the others are pretty much a catch. I'll take some raised hands now. A catch. Now I can see. I was not able to see earlier. Welcome. A catch. A call, Marco. Welcome. Akesh, can you hear us?
I raised hand
Yes, there you go.
before. Yes, I can hear you.
Wonderful. Please
Yeah,
proceed to ask your question.
raised hand before because I was not hearing your voice. Yeah, but
Oh, I see. No problem. Now you can hear, so that's good. I think it was your audio that had an issue. All right. So how can we use probit, logit, and tobit analysis? I won't go into that. A lot of you are actually deepening the overview topic into an advanced level one. So has anybody answered the software that are best for data storage? Tanaka Mudada had asked that. Okay. Did anybody send an answer for that? Okay. So I see now that at least we've had a wonderful session for Q&A, and thank you all for your kind attention. Somebody answering probit logic is when your dependent variable is binary. Yeah. So if there's a question that's outside of this scope that's actually showing that we need another training and another webinar on a different day. So thank you all for your kind participation. All right. So on that note, I think I'll call it a day. Goodbye.
More than 168 million people in over 50 countries are in need of humanitarian aid. Highly violent conflicts are causing widespread hunger, displacement, human suffering, death, and destruction around the world. Now more than ever, there's an acute need for skilled humanitarian manpower to match the growing need. It's time to take action and grow your career in the humanitarian sector. Welcome to Strategia Netherlands. We are an international organization that aims at making development and humanitarian work more effective. We're an independent and private provider of online and distance learning in humanitarian courses. Our mission is to provide our clients with relevant and high-quality courses to propel them to the heights of their choice careers. With over 300 exciting career-focused courses to choose from at Strategia Netherlands, our students are imparted with skills that greatly increase their prospects for employment as well as value to employers. Our students work for international organizations such as the United Nations and national and international non-governmental organizations and various governments. You can now apply online for diploma and postgraduate courses with a flexible schedule that allows you to study and maintain full-time employment. Apply now for a diploma in monitoring and evaluation, diploma in conflict management, diploma in leadership and management, diploma in humanitarian logistics, diploma in community development, diploma in grants management, diploma in disaster management, diploma in water, sanitation and hygiene, diploma in gender development, and diploma in food security and nutrition in humanitarian emergencies. The cost for diploma courses is 800 euros, while postgraduate courses cost 1,200 euros. Visit www.strategianetherlands.eu for more information. Take action and register today.